Hello, welcome to Chapter 3, Section 3, Solving Systems of Linear Inequalities. All the stuff that we're going to do in this video or in this section, you've already done before. It was in Chapter 2, Section 5, I believe, where we were learning about graphing one linear inequality. So basically you had that one. Now we're going to do two of them together. And in a couple of examples later, we're going to do more than two. We're going to see what happens with that. This is a big part of the project that's coming up in the next section, 3-4 linear programming. So make sure you get all your questions answered. Okay? Here's what we remember from doing it the first time. We need to figure out where we're going to graph the boundary line. We need to figure out if that boundary line is solid with no breaks or dashed, and what does that mean? And we need to figure out if we're going to shade above the line or below the line. The only difference between what we did before and what we're doing now, we're going to do it with two of them. So let's get started. The first, y is less than or equal to negative 2x plus 4. The boundary line is y equals negative 2x plus 4. This is in slope-intercept form, so I can tell that my slope is going to be negative 2 over 1, and my y-intercept is going to be 4. So I'm going to plot some points here, and I'm going to figure out where this boundary line is going to go. And then my next step, I'm going to figure out, do I draw dashed or solid? So my y-intercept is at 4 on the y-axis, which is right there. My slope is negative 2 over 1. Remember that the slope is the change in y over the change in x. Don't say rise over run. This tells me how far up or down to go, and this tells me how far right or left to go. Negative 2 means go down 2. Positive 1, I'll put the plus sign in there. Positive 1 tells me to go to the right 1. So I go down 2, right 1. Down 2, right 1. Down 2, right 1. And I'm going to keep doing that until I go off the grid. And not only that, but I'm also going to go the other direction. Negative 2 over 1 is the same as positive 2 over negative 1. So I can go up 2 and to the left 1. So it looks like I'm going to be drawing my line through here. Now if I look at this, this tells me that when I have y is less than or equal to negative 2x plus 4. I'm going to rewrite that. This tells me that I'm going to have a solid line because of the equals part. So I'll try drawing that all the way through. Didn't mean to put a gap there. Just didn't finish all the way. And notice that I'm not drawing arrows on this line to meet with the IB requirements. Finally, I need to figure out if I'm going to shade above or below it. Okay, this negative 2x plus 4, that is the boundary line, okay? Y equals negative 2x plus 4, that's the boundary line. And the y coordinates that are equal to that expression are on the boundary line. For the inequality, the y coordinates of the points are going to be below the boundary line and also on it, but they're going to be below the boundary line. That's one way of checking. You can also check one point here and one point somewhere else and then see if you got it. But these are both in slope-intercept form where the less than or greater than is going to tell me what I'm going to do. Okay? Now, before you start to just color this side in, I want you to wait because we have another inequality we need to graph. So what I'm going to do, I'm just going to start my shading by making little marks along the edge. That's just a visual cue for myself, knowing that if it was just for this one inequality, I'd be finished. I would graph it all the way. But I need to do the other one. The boundary line is going to be y equals x subtract 3. My slope is positive 1. I'm going to make that into a fraction. Positive 1 over positive 1. And my y-intercept is going to be negative 3. So going to my y-intercept on my y-axis, and my slope, that's up, sorry, get the hiccups. That's up 1, right 1. So I go up and to the right, up 1 to the right 1, up 1 to the right 1. And I do that until I go off the grid. This is also a negative divided by negative, which equals positive. So -1 over -1 tells me go down and to the left. And I keep doing that, and you'll notice that these are all in a line. That's my boundary line. Now the original inequality was y is greater than x minus 3. That tells me that I'm going to use a dashed line. So I'm going to do this. And hopefully you can tell the difference between the solid line and the dashed line. This is my boundary line, x minus 3. That's my y-coordinates of all the points that are in the inequality. Since the y-coordinates are greater than the boundary line, that means I'm going to shade above. So the shade, oops, almost did it on the wrong one. The shading is going to be above this line, but not equal to the line. Okay, now I'm going to put these things together. I have 4 sections, not counting the boundary lines. I have this part in the top, this part on the right, this part on the bottom, and this part over here on the left. It looks like I shade below this line and I shade above this line. I want to know where the overlap is. So my shading is going to look like this. And again, we're not going to like shade, don't color it in like that. All right. All right, now I'm going to switch here for a second. And I'm going to pull up Desmos on the iPad. I'll move this so you don't get a reflection off the glass. There's a little bit of reflection. Okay. So here's what I did. You gotta remember what they were. I'll put them right there. I'll put it right there so you can see it. So I'm gonna do, where's my y? Right there. What? I never use the on-screen. I always use laptop. Y is less than or equal to negative 2x plus 4. Okay, now compare that with what I did. Here's my boundary line, and I shaded below it. That's what we did here. And look, it's a solid line. Desmos does a solid line. Let's do the other one, and this one's gonna, that one was red. Desmos does colors, that's great. The other one is gonna be y is greater than x subtract 3. All right, now check out what just happened. Dashed line, solid line. The red line shaded below it, the blue line shaded above it. And the overlap is this area right here that's purple. Now compare that to my graph that you're looking at right there. So you can do this with Desmos. Keep that in mind. Let's do another one. So for the first inequality, my boundary line is y equals 3 over 2x plus 2. My slope is 3 over 2, and my y-intercept is 2. So here's my y-intercept, and my slope is 3 over 2. Now notice that my scale that I'm using here, I put a bigger scale in this one. Okay, notice that my scale is every 2, but that's okay. I can still go up 3 spaces and to the right 2. Okay, that's like going, that's like saying 6 over 4. So I'm going up 6 and to the right 4. That's the same fraction. And then I can also go down and to the left. And I think I'm going to end up there also. All right, so my original inequality, which is just right there, is greater than or equal to. So this means that I'm going to have a solid line, and I'm going to shade above. So I'll try to draw that solid line without a ruler. And again, I'm going from one edge to the other edge, in this case from the bottom to the top. But always make sure you go all the way off the edge of the graph. Don't stop it in the middle. And I'm going to shade above this. So again, like I did last time, I'm just going to put little marks right here. All right? That tells me when I'm finished, I'm going to shade above it. For the second one, this one looks a little confusing. What does that mean? Well, the boundary line is x equals 3. This is going to be a vertical line. It's actually not even a linear function, it's a vertical line. And it's going to go through where x equals 3, which is right here. So I'm going to draw a vertical line going this way. Before I do it, is it solid or dashed? It's going to be dashed. So I'm going to make my dashed line just like this. And again, going all the way from the top to the bottom, bottom to the top. And which side am I going to shade? I'm going to shade to the left. I want the x's that are less than 3. So I'm going to actually shade this way. So just like last time, sorry about the phone, just like last time, I've got 1, 2, 3, 4 sections. And it's this section over here on above this line and to the left of that line that's going to be my overlap. So it's going to look like this. Now let's switch over and look at that, see how Desmos looks at this, okay? So I have y is greater than or equal to 3/2 x plus 2. So that, hopefully that looks like what I drew right there. Solid line, shade above it. Now the other one, don't be concerned by the fact that it is a vertical line. I have x is less than 3. And this time Desmos rotated through purple. So here's my first, move that so you can see it. There's my first inequality, there's my second inequality, and there's the overlap, this grayish area, purple, green. That's the overlap. And that matches up with what it is here. It's actually easier to see it on this one than it is on that one, because this I wanted this one to go up to 10. That's why the scale is greater than the other one, than the one I used in the previous problem. But one thing you can also do, you can zoom this out a little bit and take a longer look at it. All right? Okay, I'll see you in the next video.